This is a video on determining if a sequence converges or diverges. The question states, determine if the sequence with nth term, a sub n, is equal to 1 plus 2 over n to the nth power, converges or diverges. So in order to find whether a sequence converges or diverges, what we do is we take the limit as n approaches infinity of our a sub n. And let's do that, and I'm going to set that equal to y. So I get y equals the limit as n approaches infinity of 1 plus 2 over n to the nth power. Now I'm going to use a little trick. I have an exponent up here, and I can move the exponent over by taking a natural log of both sides. So I get the natural log of y is equal to the limit as n approaches infinity of the natural log of 1 plus 2 over n to the nth power. And now I can move the n over, that's a log rule, and that's equal to the limit as n times the natural log of 1 plus 2 over n. I'd like to use L'Hopital's rule, but I don't have this n in a denominator, so I will put it in the denominator as a 1 over n. So that n got moved downstairs as a 1 over n. And now I can check to see if I can apply L'Hopital's rule by plugging in n equal infinity. 2 over infinity is 0. 1 plus 0 is 1. And natural log of 1 is 0. And of course, 1 over infinity is also 0. So indeed, I do approach 0 divided by 0. And I can invoke L'Hopital's rule. So let's do that. I need to take the derivative of the natural log of 1 plus 2 over n, and then I need to take the derivative of 1 over n. So to find the derivative of the numerator, I use a chain rule. The derivative of the inside, derivative of 1, is just 0, and the derivative of 2 over n is negative 2 over n squared. So there's my negative 2 over n squared. And then I take the derivative of the natural log function, and the natural log brings the inside into a denominator. And the derivative of 1 over n is negative 1 over n squared. So I've gotten rid of the natural log, and let's simplify. We have a 2 over n squared divided by 1 over n squared. That's just 2. And the negatives cancel. So I arrive at the limit as n approaches infinity of, there's our 2 from before, and we still have 1 plus 2 over n in the denominator. So now I can plug in n equals infinity. 2 over infinity is approaching 0, and I get 2 over 1 plus 0, and that's just 2. Now, that's not my limit. That's the limit of the natural log of y. If I want to find out what the limit of y is, I take e to both sides, and I get that y is equal to e squared. And I'm ready to state my conclusion. I can conclude that the sequence converges. When we do have a limit, the sequence converges, and it converges to e squared. And I'm done with the problem.